Hi there, this is Professor Shannon Gracie, and we are working out of Robert Blitzer's Introductory and Intermediate Algebra for College Students textbook. We are now on section 5.5, which covers dividing polynomials. When you're done with your homework, you should be able to use the quotient, zero-exponent, quotients-to-power rule for exponents, and divide monomials, check polynomial division, and divide a polynomial by a monomial. All right, so here we go. Go ahead and warm up. We've got 2 warm-ups here. Ready? On your mark, get set, go. Pause the movie and warm up. All right, let's see what we have going on with the first one. See how you did. Notice that, this factor of x divided out this one. So those ended up being 1, 1, and 1. And then we had 8 factors of x. So 3 of them were divided out by the denominator, which had 3 factors of x, right? So basically, the point I was trying to get across here is that this ends up being x to the 5th, but looking at, another rule for exponents, do you see that this also, we could think of it as x to the 8 minus 3, right? So there's a relationship there. I mean, this is the answer. How did we get there? Well, when you're dividing same base, it looks like you do what with the exponents? Good, subtract. Okay. All right, and then this guy gives us 2 to the 5th, a to the 3 times 5 over b to the 4 times 5. This is the product to powers rule, right? And then we will get 2 to the 5th is 32. A to the 3 times 5 is a to the 15th over b to the 20th. And we're good to go. All right. How'd you guys do? Awesome. I know you can do it. Okay, so here we go. The quotient rule for exponents. If you have b, we'll need more room, b to the m divided by b to the n, that is equal to b raised to the m minus n. When dividing exponential expressions with the same non-zero base, subtract the exponent in the denominator from the exponent in the numerator. Use this difference as the exponent of the common base. Alrighty. So here's some problems to practice on. Go ahead and pause the movie and give these 2 problems a try. Alright, let's see how you did. Here we go. First check, do we have the same base? Yes, the base is 2 and it's the same. So since we have the same base and there's nothing else going on, this is equivalent to 2 to the 5 minus 3. And this gives us 2 squared, which gives us an end result of 4. Okay. I highly recommend you do this step right here, because a lot of times people skip it and just do it in their head, and it doesn't, if you don't actually show your use of the rule enough, it's easy for it to slip from your mind. Okay, so next up, Do we have the same base? Well, the bases are each x, so yes. So therefore, we can write this as x raised to the 10 minus 8, which is x squared. Now we do not know what x is, so therefore we're done. X squared is our result. Okay, next up we have the zero exponent rule. So, all right, the zero exponent rule actually is this. If b is any real number other than 0, b raised to the 0 power is equal to 1. Right? So here we go. Simplify each expression. Okay, well, here, there's a couple ways to go about it. You could recognize that this quantity is being raised to the 0, so you're just going to get 1. Or you could go through and you could say, okay, 4 squared is 16. I'm raising that to the 0, and that's just going to be 1. Right? Okay, now be careful with part B. Part B, if you read this out loud, which I highly recommend that you do, you would have negative 7 times x raised to the 0. So exponentiation comes first. So we're going to let this negative 7 go along for the ride. X to the 0 is 1. So here we evaluated this portion of it to get 1. And then this ends up being negative 7. All right. On to the next. The quotients-to-powers rule for exponents. If a and b are real numbers and b is non-zero, then a divided by b raised to the n power is equal to a to the n divided by b to the n. When a quotient is raised to a power, raise the numerator to the power and divide by the denominator raised to the power. Okay, so here we go. First one. Our numerator is x, so we raise x to the 5th and divide by 3 to the 5th. X to the 5th is x to the 5th, and then 3 to the 5th is going to be, good, 243. I'll let you pause the movie and give part B a try. Okay, so let's see how you did. Here we go. This is going to be 4x cubed squared divided by 5y, the quantity squared. So that is using the quotients-to-power rule, right? So this is using the quotients-to-powers rule. Now we're going to use products-to-powers rule from before. So this will give us 4 squared x to the 3 times 2 over 5 squared times y squared. So this is the products-to-powers. And then, of course, in the numerator, we had power raised to a power. Okay? The x to the 3 times 2 is the power raised to power. So this will be 16 x to the 6 divided by 25 y squared. We do a last check and make sure we can't simplify anymore. And we can't because we have different bases. So this is fully simplified. Okay. Dividing monomials. To divide monomials, divide the coefficients and then divide the variables use the quotient rule for exponents to divide the variables. Okay. So here we go. I'll get you started with 4A and then I'll let you work on B and C. So here we go. This is going to be, so we do our, this is going to be 16 divided by 2 and then times x to the 4 minus 4. So the second part we use the quotient rule, all right, for exponents. And the first part we're just dividing. And notice that we can do this because we have a monomial over a monomial. So 16 divided by 2 is, good, 8. And then we get x to the 0. But x to the 0 is 1. So our end result is 8. So here we go. X to the 4th over x to the 4th resulted in this, which resulted in this, which resulted in this. And then the constant was 16 divided by 2, and that's how we got the 8. Okay, so here we go. Pause the movie and try B and C, and then go ahead and check your work. Okay, let's see how part B went. So again, we're going to have our 6 over 21. Now remember, x is the same as x to the 1. So that's going to be times x to the 2 minus 1, and then times y to the 5 minus 3. So that's where we got that. And then the yellow is the y's. All right, now do you see that 3 divides both 6 and 21? So that simplifies to be 2/7 x to the 1 y squared. So I'm not sure how the homework online is going to have it. On the exam, I'm okay if you write it as 2/7 xy squared, or you could write it as 2 times xy squared all over 7. Okay? So either result is fine with me. And again, this is how the x's worked out, and this is how the y's worked out. How'd you do? Did you get that one? Awesome. All right. Here we go. This one will be 35 divided by 14. And then times, we have r's this time, so we have r to the 8 minus 7. So this is how the r's went. And do you see that 7 divides both 35 and 14? So 7 goes into 14 twice and into 35 5 times. So we will end up with 5 halves r to the 1, which is 5 halves r, or again, we could write this as 5r all over 2. And this is how the r's turned out. Okay. So here we go with the next step. We're going to be dividing a polynomial that is not a monomial by a monomial. Okay? So in order to do this, it ends up turning into like a sum or difference of problems where you've got monomial divided by monomial like we just did. But you have to do a little bit of work to get there. So scroll down here. So here we go. This is sort of the idea behind it if you're working with numbers that you know about. Let's say that you had, like 3 plus, 3 plus 6 all over 2. Or no, let's do it all over 3 just to make it work out nice. Okay, so if you have something like that, you could actually write it. You could either, since we know the numbers, you probably would add the 3 and the 6 and look at it as 9/3. But you could look at this as 3 over 3 plus 6 over 3. Now this is the idea that we're going to be using. Now, if it was the other way around, if the 3 plus 6 had been in the denominator, you cannot split it. But if you have a monomial, a single term in the denominator, you can split a polynomial that's a binomial or more terms, like we did here. So here we go. To divide by a monomial, divide each term of the numerator by the monomial, or actually we'll be specific, by the denominator, the monomial that's in the denominator. Okay? So here we go. Just so that we're squared away here. The terms of the numerator in this case, the dividend, are 24x to the 6 is one term, negative 12x to the 4th is the second term, and positive 8x cubed is the third term. You've got a trinomial. Okay? The divisor, the denominator, is a monomial. 4x cubed is one term, so it's a monomial. So here we go. This is going to be equal to 24x to the 6 divided by, I'm going to use the fraction bar as divided by, 4x cubed. Do you see that's a problem just like what we were working on in the last ones? And then we have to finish it off. Minus 12x to the 4th over 4x cubed, and then plus 8x cubed over 4x cubed. So I divided through each term, got divided by that 4x cubed. All right. Another way one could think about it is multiplying by 1 over 4x cubed. So whatever works for you, that's how you do it. Okay, so 24 divided by 4 is 6. And then we'll have x to the 6 minus 3. Minus 12 divided by 4 is 3. Then we get x to the 4 minus 3. And 8 divided by 4 is 2. We get x to the 3 minus 3. So in this one, that's how we did the variables. In this guy, that's how we divided the variables. And then in the third one, this is how we use the rules of exponents to divide the variables. So this will be 6x cubed minus 3x to the 1 plus 2x to the 0, which is 6x cubed minus 3x plus 2, because x to the 0 is 1. Okay, so this next one, it looks a little bit different, but it's more of the same. All right, you have a monomial divisor that's in the, your denominator, the negative 9x cubed y. And then you have another trinomial that's in the numerator. So here we go. This will be 459x to the 10th, y to the 9th, divided by negative 9x cubed y. And then we'll have plus 18x to the 5th y cubed divided by negative 9x cubed y minus 9x to the 4th y divided by negative 9x cubed y. So here we go. 459 divided by negative 9 will be negative 51 x to the 10 minus 3 y to the 9 minus 1. Then we have plus and negative, so we're going to have a minus, and then 9 goes into 18 two times. And then we get x to the 5 minus 3, and we get y to the 3 minus 1. Minus and minus is plus. 1 x to the 4 minus 3, y to the 1 minus 1. All right, so here we go. We'll get negative 51 x to the 7th, y to the 8th, minus 2x squared, y squared, plus x to the 1, y to the 0, which will give us negative 51 x to the 7th, y to the 8th, minus 2x squared, y squared, plus x times 1. I'll write that in. Okay. Because remember, y to the 0 is 1. And then we'll get negative 51 x to the 7th, y to the 8th, minus 2x squared, y squared, plus x. And we are done. And by the way, I can write one more line here for this problem in case you were confused. X to the 0 is 1. So right here, this part of it, we got this result. So our end result for this problem would be equals 6x cubed minus 3x plus 2. All right, so we're done with section 5.5, and go ahead and do your homework problems for this section, and have a wonderful day. Bye.